It's not as much coding, but yes. Yeah, body. I'm body. Oh, really? Okay. Okay, maybe something like that one before, you know, so yeah, I use
Hi, everyone. Welcome to Southwest Florida Coders. My name is Crystal. This is Arella, and we are the organizers for Southwest Florida Coders. I see a lot of new faces in here today. Welcome. This is exciting. This is a new room for us as well. And, you know, I hope you enjoyed today's presentation. So moving on. As you can see, we are basically on most of the social medias. We got Facebook, X, LinkedIn, YouTube, and Slack. If you would like to join our Slack, then please go ahead and send a message to either Zarella and I, and we will be able to add you in. Let me go ahead and mute this really quick.
It's not me. Yeah.
So Southwest Florida Coders. What's the what? Oh, it's that. Wait, so we're gonna have to deal with a little bit of feedback temporarily. But Southwest Florida Coders is part of the Tech Alliance of Southwest Florida, which is an organization that umbrellas several different groups overall. We got Southwest Florida Stack, Southwest Florida Coders, ARVR Southwest Florida, Python Southwest Florida, Southwest Florida Hackerspace, and Music Makers of Southwest Florida. Next, we have our code of conduct. If you would like to take a moment to take a shot of the QR code, it will bring you to our document and let you know our guidelines when it concerns participating within the group, and I believe for the Tech Alliance as well. Awesome. We also, no, it's that thing. We also are on Discord. If you would like to join the Tech Alliance Discord, feel free to scan the QR code, and it should add you in. I'll give it just a second. All right, and if you didn't get it and you still want it, come talk to us and we'll get you in there.
Okay. Hi, everyone. Before I go to the calendar, I'd like to just get a gauge of how many people are here for the first time at this place, okay? Oh, yeah, it's awesome. Thank you. I hope you like it here. And, you know, just as Crystal mentioned, we're part of a Tech Alliance. And because that's actually our next event coming up, just wanted to really tell you a little bit of the Tech Alliance. It's basically like our umbrella organization that started with this group, but then encompasses all our sister groups that became really like a very nice and tight community. So I really, really encourage you to come next week. It's going to be on Thursday, but we're going to be on the bigger room here at Collaboratory as well. And normally we have a few events per year. But for this year, at least, we are really want to focus on our groups. So we're only going to have one event for the Tech Alliance, and it's going to be like a New Year party where we're going to be showcasing our groups and as well the things that are happening within our community groups. So we would love to have you here. We'll have some beverage and some snacks and stuff like that. So please come. That's going to be next week here. And then the next event on Friday is going to be for Southwest Florida Tech, and it's called Whoopsies, Mistakes in Cybersecurity and How to Deal with Them. That's going to be in person at FSW, but also they also going to have a remote option available. The next event on February 11 is going to be for the Southwest Florida Hackerspace. And that's going to be at the Retro Zone Arcade. If you haven't been there, please join. I think some of us been there. It's just a lot of fun. And then our next event is going to be on February 13 for where our dog is just to be determined, but it's going to be on the 13th, and it's going to be also here at Collaboratory. Okay, and we've been doing all the talking, so this is the time that you get to talk and just tell us your needs. If there's anybody here that is looking for a job, or the company that you're working for is hiring, or just really anything that you need, please feel free to use this time to do it. Anyone? No? Okay. Alrighty, so now we're gonna give the welcome to our speaker, Felix. Just give me 1 second. About Felix, Felix has 20 years of experience in technical roles within enterprise services and software, where he designed, architected, and built market-leading and leading products. Currently, he's serving as VP of software development department at Coal miners, and he also dedicates his free time as a scoutmaster for local Boy Scouts. So please give a welcome to Felix.
All right.
Okay. Okay.
All right. Perfect. I love the echo. It's like I'm in a massive arena. So that's great. My name is Felix. Nice to meet y'all. I don't think I've met many of you guys, but that's okay. We'll be best friends by the end of the night, hopefully. I want to start out with if I can get this thing to work. Start out with a tiny disclaimer, and that is the views and opinions expressed in this presentation are solely my own. They're not my employer's. They don't reflect the views, policies, positions of my employer or any affiliated organization. So I'm just putting that out there.
You guys having
Yes,
issue with
we're having
the sound?
an awesome echo. You hear it? Echo? Kind of,
Oh,
maybe
yeah,
a little bit.
oh,
What's going on with that guy up there?
There's an echo going on in the apartment lounge with the sound system.
Okay, so the sound comes out of the TV.
Okay.
If we're hearing sound out of the speakers, we've got to mute it.
You said it's coming from
Sound is
the
not
speaker.
integrated.
Yeah, we muted the TV.
They've
Oh,
already
TV.
muted the TV. Okay, it's a speaker.
The speakers in the room are, can you go, Alani, I'd like you to go to the front iPad option settings.
Okay.
Sweet. Good thing we're all software people, not hardware people, so we don't have to deal with this. I used to be a hardware person, and I loved hardware actually because it's nice and heavy. Okay, so agenda, what we're gonna go about today. We're gonna go over tools for proof of concept and production. We're gonna go over how to select a model, how to rapidly iterate on ideas, and staying agile in your process in order to rapidly iterate to get towards somewhere. How to learn and stay up to date, because GenAI and everything around models these days is moving very, very, very quickly. Am I speaking loud enough? Can everyone hear me? Okay, good. Estimating costs, that's a big one, because just like in AWS, you can go broke real fast if you really leave everything running at full volume. How to handle scale, right? Everything doing it on your laptop is easy, right? But when you try to scale it, that's when it becomes a little bit hard. And then we're going to touch a little bit on how to deal with bias, data privacy, safety, security, and regulations, and then have a Q&A. That being said, if there's any questions throughout, just raise your hand. It's fine. We can stop. We're going to have a whiteboard, but I'll try to illustrate everything we're talking about just fine. Just a quick show of hands, just so I have an idea of what kind of audience we're dealing with. Is anyone working in tech? Almost everyone. We have some students. Got some students. Okay, good. In tech, are you management? All right. Are you hands-on? Okay, IT. A little bit. Okay, development. Okay, design. Product. Okay, cool. So we got a real nice mix of everything. Perfect. Just like real life. If I say something that you don't understand, just raise your hand. I'm happy to elaborate. About myself. So my name is Felix. I've 20-something years in the software industry in various technical roles. Starting out as a network admin, network engineer, and now I'm a VP of software development for CallMiner. Got a team of 100 or so. Our product. The company CallMiner I work for is CX and EX Analytics SaaS vendor. CX being customer experience, EX being employee experience. Think of it if you have a contact center, if you have any kind of customers, you're interacting with them, right? Whether it's over voice or text channels, right? You want to analyze those interactions. To deal with your contact center, right? You want to be able to train and manage your agents, and maybe even reward them based on their performance. You don't want that done with manual reviews, right? You want that automatically across 100% of your interactions, as well as figuring out what's going on. Why are people calling us, right? For example, back in the day when we had Microsoft as one of our customers, they were really interested in the Xbox launch when the first Xbox came out. Remember how they caught fire? Our system flagged that to them, and they're like, "Oh, why are all these people calling about the Xbox being on fire?" And they had to do something real quick. That was a good time. Eventually they dropped us as a customer because they were like, we love the analytics and we're not actually doing anything with the results. One thing I'm really proud of is that our product is the leader in the Gartner Magic Quadrant for our industry. That means we're at top to the right. We have the best vision, the best product, and the best market footprint out there. And that is something that my team and I have worked very, very, very hard for many years, and we're exceedingly proud of it. And that's a super awesome thing. So I like to sometimes, I can't show the thing without giving you a press release or whatever, but just imagine like a graph, and we're in the top to the right where you want to be. And everyone else is somewhere else. And I've had a deep AI focus for the last 2 years or so. I'm married, I have 2 kids. I'm just realizing that this slide is slightly out of date. I have 2 dogs now because we just adopted one on Saturday. And I'm also a Scoutmaster for Boy Scouts of America Troop 193 here in Fort Myers. So terminology-wise, I'm going to use LLM and model fairly interchangeably on these slides. Yes, a model can mean a lot of things, cost modeling, etc. So in the later slides, when I'm talking about costs, and I say cost model, and model your costs. I'm not talking about LLMs there. I'm talking about the actual cost model. I also consider SLMs, MOEs, and others. So small language models, mixture of expert models, etc. All those families. When I say LLM and model, so we don't split hairs all day. Just think if I talk about model, unless it seems to be about cost, it's like an LLM, a large language model. Okay, so let's jump right into it. Tools for proof of concept and production. This is all stuff that's hard won over the last 2 years of experience in the industry. Just to give you an idea of what the kind of stuff we're building with it is, obviously starting out with the super basic RAG concepts, and then expanding those pipelines into fancy router-based systems, etc. And then going into agentic flows, and basically automating the analytics process away from our users to make them be able to focus on actually getting ROI out of the system rather than dealing with any of the analytics themselves. In terms of tools to use, so let's go over platforms and providers. So a lot of different platforms out there that give you access to these models, right? You can obviously download some from Hugging Face, and you can run them locally, run on your graphics card, right? But those are fairly small models, right? And they're fairly limited in capability. If you want to use the higher capability items, generally you either have to buy a really fancy 100K server with a bunch of H100s in it or something like that. GPUs, server class GPUs, right? Or you rent it from one of the big boys, generally one of the hyperscalers or one of the other companies. Hyperscalers wise, right? You've got Azure OpenAI, you've got AWS Bedrock, and then you got Google, right? Google AI. These are the big boys. There's a couple of smaller ones out there, right? But those are the big boys that everyone's familiar with. And I would imagine each and every one of you has an account with at least one of those companies. Then there's the LLM companies themselves, right? That give you access to their models through some different API systems. So you've got OpenAI, you've got Anthropic, you got Cohere, you got Meta, et cetera, right? And then you've got different API providers that either just putting up their own infrastructure, or they're even developing sometimes their own chips to serve everything. Grok, for example, not to be confused with Elon's Grok. These guys building this cool little chip called something PU. What's the LPU? Language Processing Unit, LPU, which is just really a really fancy silicon wafer that is really fast at inference, which is really awesome. Then you got Databricks, you got XI, so there's your Elon, Hyperbolic, Together AI, et cetera. There's a ton of them out there, and this ecosystem is constantly evolving. I mean, 2 years ago there was basically nothing. Now you've got a million little niche vendors. It's going to consolidate a little bit again. Then you're going to get some people that putting their own chips out that are starting to like for example, Hyperbolic and Databricks got some cool stuff in the works. But it's constantly changing, right? The easy bet is you go with one of the hyperscalers because it's tried and true. You probably already have your billing set up, right? Easy to go with it. But there is a good resource for this overview, artificialanalysis.ai. So I should have probably pulled that site up beforehand, but basically it gives you an easy way to compare both different models that are out there. So you can compare them to the different benchmarks as well as the pricing and the performance of the different API providers that are out there. And they've got, there's like 150 or so different API providers you can look through. So if you're interested in knowing, okay, for this kind of model, where can I run it cheapest? Where can I run it fastest? Where can you get the best latency versus cost trade-off, right? This is a great site to go to do a little bit of that legwork. Recommendation wise, abstract your implementations, right? We're not all developers. Some of us are developers. Abstract your implementations so that you can move and or stripe across providers easily. They change their pricing, right? Sometimes they don't have enough capacity. Sometimes you can't get the model you want at the provider that you've been using. Just like in software, right? Everything changes constantly. Abstract the implementation so under the hood you can switch to a different provider at any point in time, ideally. And that's actually a theme you're going to see throughout this presentation because everything is evolving so fast constantly. The only thing constant is change. You're going to want to change and upgrade models. You want to upgrade providers, et cetera. So as you're building software, keep that in mind. All right. Languages and frameworks. There's a bunch of stuff out there, right? When it first started out, you had the LangChain was one of the early pioneers coming out that started abstracting some of the interactions with LLMs. Then they got really big and bloated. And then they kind of threw everything out and we're like, all right, we're going to start from scratch. And then they put out LangGraph, right? So it's just been kind of evolving a little bit. But I think undoubtedly Python remains the king of AI, right? You've got all of the different ML tools out there and you've got all the researchers working on it. So it just kind of comes through. Is Python always awesome to use in production? I don't know. It's kind of annoying sometimes being a little bit single-threaded, but there's worse things in the world. There's a decent evolving C# and Node ecosystem as well. But right now, if you want to be turnkey and just, I want to pull a bunch of libraries and just get cracking, Python is definitely the king of doing anything with AI currently. Now, do you want to actually use a pre-built LLM framework or build your own? That's a good question, right? And that's something that we should always ask ourselves, right? Build or buy. So interacting with LLMs is not hard. It's really easy. It's an API call. You put a little bit of stuff in it, a little prompt, you know, tell it what you want to, maybe a couple other parameters, an API key, stick that in a JSON payload, you send it out, right? And then you get a response back and you parse it, and there's the thing. It's not hard. It's you know, we work with APIs every day, all day, right? And a lot of times easy does it. Like if you don't have anything fancy you need to do, is it really a need to pull in a bunch of different third-party libraries that are going to constantly change their contracts, and you got to deal with security vulnerabilities, blah, 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 or you're just going to make a request to a URL and get your data back, right? The nice thing about frameworks is that they have ready-made model and provider abstractions, right? That kind of provides some of that flexibility already. For example, in LangChain, all you got to do if you want to use Azure versus OpenAI versus Google, you change environment variable. Boom, you know, I'm over there. I got my new API key in place, and it just works. Same if I want to go between, you know, maybe I don't know, one of the llamas and one of the GPT models. It's just a couple of lines of configuration. So that is definitely an advantage. On top of it, the frameworks codify emerging design patterns. Developers in the house, you guys know and love design patterns. They're good. They're blueprints for getting something done. They're great for communicating with other developers, right? I got a chain of responsibility. Okay, cool. I know what that is. Single responsibility. I got you know, a singleton over here. Cool. I don't have to explain to you all of computer science. You know what that is, right? Same thing with these frameworks, right? And we've got a bunch of different emerging architectures coming out. Or design patterns in interacting with LLMs like chain of thought, RAG, right? Retrieval augmented generation. The nice thing about the frameworks is that they codify those patterns, which means as you get started, you don't have to read a whole bunch of research papers and do a bunch of trial and error to apply a basic chain of thought algorithm to your interactions, right? Or maybe doing a basic RAG setup. You can do it with a few lines of code because it's all abstracted for you. Which is awesome when you get them started, when you're prototyping, because you can really, really fast put something together that's good enough to bring the concept across, right? Maybe sell it to product, maybe sell it to that investor, and get that buy-in for actually building something production quality. At some point, you're probably going to realize that, hey, you know what? I now know more than this thing, and I'm going to build my own implementation of this because I have more advanced needs, right? But to get started and for learning, it's perfect because you can skip all the hard part. Now, do you always have to skip the hard part? No, there's definitely some value in hitting the books and learning, right? But if you got to spend a year in school in order to build a prototype of an idea that you want to scratch, you're probably not going to do it, right? It's much better to scratch that itch and then maybe see if you got something, and then you can start laying in some additional theory to get really fancy. There's a bunch of different frameworks out there, and I apologize if this is large enough. I didn't know that the screen would be a little small. But LangChain and LangGraph are out there. Llama Index, Haystack, Semantic Kernel, and a bunch of others. Personally, after we evaluated 15 or so different ones, we settled on LangChain and recently moved to LangGraph for agentic frameworks. LangGraph is really cool for agentic frameworks because you basically your agentic flows you lay out as a graph that you can traverse with your different interactions. And if you don't know what an agentic flow is, imagine an application that has a goal and has a certain ability to sense its environment and interact with it and reason, and it will work autonomously to accomplish that goal as much as possible. An evaluation checklist when you're trying to figure out what language, what framework do I want to go with. Look at documentation quality. I mean, it's the same thing as you do with everything when you look at a third party, right? Look at your doc quality. Is it well documented? Do the docs make sense? Are they updated? When there is an issue in the docs, do the docs get updated? Community support. right? Because let's face it, not everyone's gonna buy a bunch of support contracts for every single third party we have. So, yeah, is the community active? Are any kind of issues that are being raised? Are they actually being talked about? Are they getting fixed? The ecosystem maturity. How new is this thing? What is it using? What third parties is it using? Are those secure? Are those mature? Right? And then and what actually supports all these different frameworks, right? Like for example, semantic kernel is pretty cool. It's one of the Microsoft C# ones, right? But the ecosystem around it is just not quite there. Partly because C# isn't quite where Python is in terms of AI, right? And then integration complexity. How hard is this thing to plug into your code, into your stack, right? You kind of map all those things out and have a fun week, with everyone taking a couple of them and just kind of deep dive and build a little proof of concept or something like that. Then you come together and make a pick. It's a good time if you got a team going. Any questions? Yes.
What's the name of the framework or language that you said interacts with the environment?
If it's LangChain, that I was talking about before, I think. Yeah, LangChain and LangGraph. So LangGraph is basically the evolution of LangChain and uses LangChain under the hood for certain things. You can probably just go directly to LangGraph so you can skip a step on there. It's Python. The docs are pretty good. So that was actually the worst part in our eval checklist. Was that the LangChain docs are frequently out of date and everyone complains about them. But their CEO is also really active on Reddit, and you can complain at him. And he's like, "Yeah, I know, we're working on it," which is kind of fun. Techies. Yes.
In your research on these various tools, did you come across any that incorporated cryptocurrency blockchains like as part of RAG?
Aha. The question is, I don't know if we have a bunch of people on Zoom, but the question is, are any of those frameworks incorporating blockchain cryptocurrency? Not directly. So these are generally purpose-built towards interacting with LLMs and the flows around it. That being said, the more mature ecosystems will have integrations. I don't know off the top of my head if LangChain has that, but I bet it does because it has a huge list of just different integrations going on. It's basically they were the first guys. They were the name of the game, open source out there, and they just really went deep and wide, right? Which also is one of the reasons why the docs are kind of a little wild sometimes, because you go to some of the more obscure areas and that's where it's a little bit out of date, right? But LangGraph is working on fixing a lot of those things.
Where does replicate fit into all this?
Is that replicate it or
No,
replicate? Replicate.
Yeah, that's basically they host a bunch of different models. They
Aha.
constantly refresh it. I use their playground all the time. And it's fun.
Let me check on that real quick. How do I get rid of this bar up here? I don't know. Replicate?
Replicate.com.
Run an API with an API. Okay.
I've been using them for about 2 years now.
Yeah.
It is. We've just had some amazing models come through there, and hooking up with we're making an AI app ourselves. We're pretty well on our way, and so we use Replicate for most of the heavy lifting.
Okay. Yeah, it looks like
We think it's
yeah, it's pretty similar to LangChain, I would say. Except they're also hosting all the models for you, right? Yeah, nice.
and you just connect up the API and you're good to go.
Love it. What's their pricing like?
It's actually really good.
$504 an hour. Okay.
But they have public models, that all you need to do is just ping the public model, and it's always warm. So the problem is that these things have cold boot issues.
Mm-hmm.
So they get around the cold boot by having popular models that a lot of people use, and they keep it warm the whole time. and you're not paying those costs to keeping the server on, like you do with Bedrock or some of those.
Nice. It looks like they got mostly the open source models out there, right?
Oh, yeah. They're
Okay.
Straight up, when it comes out, if you go to, Explore tab at the top, you'll see like they're doing video now, is kind of the big thing. So if any of these things look kind of newer to you, it's because open source version comes out like literally 2 days before now.
Very cool. Yeah, so there's a huge amount of ecosystem out there, right? And this is I mean, this is really nice when you're getting started, right? You've got your hosting provider set up. All you got to do is probably put in your API key in, it looks like, and say I want this model, here's my prompt, and get going, right?
Yep.
Which is about the same complexity as LangChain, except that it also abstracts all the hosting for you, so that's nice.
That's what I was trying to do. So it's literally like LangChain, but with hosting on top of it.
Very cool. Well, let's add that to the slideshow for next time. Actually, any more questions on that before I move on? Awesome. Prototyping. That's one of my favorite stages because that's one of the few times I get to actually still write code. As any good manager in development will tell you, I shouldn't be the one coding because I'm not the closest to the code anymore. There's people for that. But I love prototyping, and especially when there's an idea, right? Or you talk with a couple of product people like, oh, this and that, like you just sit down over lunch and just hack something, and you show it to them, and they're like, oh, that's awesome, and then you get to build it, and 6 months later, it's the product. Yes, this is peak development. I love it. Which is probably one of my favorite parts about my job is having that. Be able to do an idea, prototype it out, and then having other people do actually all the hard work of productizing it. Maybe I'm a little bit, maybe it's a little bit unfair, but it's nice to be on top sometimes. So most platforms and most platform providers provide an interactive playground, like we just saw over at Replicate, right? And it's great for quick testing of prompts. So I want to try something out. I've got an idea. How does this thing work? I can dial up whatever ChatGPT and try it out, right? Here's like a spreadsheet, and I want you to do this and see what the output is, right? Most providers have an equivalent of that kind of playground out there that you can use. If you want to get a little bit fancier, there's a really cool open source tool called LibreChat that I'm a big fan of. LibreChat is basically a ChatGPT UI clone that you hook up to any kind of model and any kind of provider. You run it locally, in a Docker image, or you put it out in your Kate's node somewhere, right? And it's really neat for sharing LLM access, especially with less technical users. Because if you know how to use an API, okay, cool. Here's your key. Go do what you want to do, right? But you go over to one of your product guys and you're like, oh, here's an API key. You want to try this thing out? This model's so cool. You can do this thing and automate your meeting notes or whatever, right? And they're like, what? So instead, rather than buying everyone a ChatGPT $30 a month account, I want to buy myself one API key, and I'm going to go into LibreChat and plug it in there, and I'm going to give them the URL to my internal LibreChat and say, hey, here you go. Here's your access to whatever, GPT-4, right? Except, so we're doing that internally. That's how we're serving just bare model access to non-developers across the company and across a bunch of different providers, because you'll see even later in the presentation, one of the best ways to learn is to work with these things and understand that capability by having them succeed and fail, and see it to what degree they fail, what degree they succeed, and how to work with them, right? I'm sure all of you guys have used ChatGPT, right? Especially when it first came out, and now, right? Capabilities are very different. But at some point it clicks. You're like, okay, I know what I can use this thing for, and I know what it sucks at, right? And getting people to understand that is a great way of learning AI, demystifying it. It's not just this big cool thing or whatever. Well, it's a cool thing, and it's a big thing, but it's not a mystery because I can interact with it. And being able to do work with a bunch of different models without having to become the best programmer in the world really helps you understand the different capabilities and understand what the different providers and what the different open source models can do, right? So we're serving a bunch of different Llama versions, all of the GPTs, the Mistrals, Anthropic, and whatnot. So you can actually compare and contrast. For example, I really like Llama 3 for writing emails because the GPT models have a worse version of it. However, GPT-4o Mini is really great at writing my pull request messages. So yeah, I use different ones. And so that's the easy way to share that LLM access without also going completely poor, because you don't have to give 50 people a $30 a month account. You just get yourself the API account and pay for your usage. Jupyter notebooks, which some of you have probably used in Python, right? Are really cool for quickly iterating on some more complex interactions, right? If you don't know what that is, imagine it's a text editor where you write some code and you hit F5 and it executes it, but you don't necessarily have to persist anything. It sits there, it actually saves the results along with it. So it's really cool to like just quickly try something out, change it around, and maybe even share that with someone without having to go deep into trying to code something. Quickly serving your POC in fast API in Python is super. I mean, it takes like 2 minutes, and you have an API app running. Stick it in a container, just fire it off somewhere, and next thing you know, you got your API running out there of your prototype, and start plugging it into the rest of your stack. If you're not familiar with fast API, ask ChatGPT. It'll give you an example. You copy and paste and click go, and there you go. Your Docker is running with an API of your application. When you first started, I'll always say, don't use in production, but that's okay. I don't use it in production, but I certainly use it internally for a bunch of Slack bots, and it's super stable so far. In 2 years, it hasn't gone down once, which is actually better than our own apps, because those have sometimes a 7-1 outage. I'm sure everyone can relate. Moving on, prompt foo. Prompt foo for iterating on and evaluating prompts and A/B testing. What is prompt foo? Think of prompt foo as unit testing for prompts. And when I say a prompt is a set of instructions that you feed to an LLM, potentially with a couple of hyperparameters like how creative you want it to be, something like that, right? Do you want it to be very factual? Do you want it basically dialing out the randomness factor? Prompt foo is basically a YAML file where you lay out, these are my LLM endpoints. These are the parameters I want to send to it. This is the prompt I want to send to it. And these are the variables that I want to plug into the prompt. And then just like in a unit test, right? Your first, what's the first A? I always forget the first A. Act, something that's certain. What's the first A? I don't know. You know this stuff. You're in management too, so you forget. It's okay. Either way, so you set everything up and then you run it, and so you can run your prompt through with many different inputs automatically against many different versions of a model, or the same model, or different versions of your prompt and different versions of your input against, and then you can have assertions on it. You can make sure that the data that comes back from the model is what you expect. It could be that's the JSON that comes back from it, because maybe I had to create some JSON or some XML or something like that, right? Is it actually proper syntax? Does it have the fields I want? Did it write the right things in the summary of this transcript that I told, right? Does it make factual sense, the answer? You can actually have another LLM evaluate the output of it and make sure, well, is this right? Is this not? Is this wrong? And I'll show you guys prompt foo in a little bit, so don't worry. But it's promptfoo.dev, I think. It's really neat. Think of it as unit testing for your prompt. So when you actually go into production with these things, right, you need to be able to A/B test, right? When you start changing your prompts around, you're iterating on them. Does this thing actually work better than this thing? Yes, vibe check works, right? And that's great at prototyping land. But once you actually go into production, you got to have more than just a vibe check. And ideally, you want to automate that, right? Because what do unit tests give us, right? They protect us from regressions, right? Ideally reduce some of the test burden, and they let us iterate on our system. And when we break one thing in our massive complex system, a unit test can help us learn where we actually broke it and what other things we broke by changing this one little thing here. All of a sudden, something else broke here. In agentic flows, that's really important because an agentic flow is basically, hey, there's all this stuff going on. There's all these different things doing things. If I change something into the prompt of this agent, did I break at this one over here at the end of the chain? I don't know unless I have automated testing on it. This is what that gives you. So just Google prompt food, start looking through it, and you'll be like, oh wow, this is really cool. You can use it for red teaming and a bunch of other stuff as well. But for essentially unit testing your prompts, I think it's invaluable. Put it into your CI/CD flow, so it automatically gives you a bunch of reports and can even alert you like, hey, this thing all of a sudden runs slow, or all of a sudden your prompt doesn't perform as well, or something breaks in your agentic chain. Langfuse for tracing. What is tracing? Just like trace logs, hey, these are all the things that happen in my application, right? Think of if you have more complicated LLM flow, right? Maybe you do a bunch of calls to it, and you have maybe you're using a model that has a small context size, but you want to operate on really large blocks of text. So maybe you split that and you have it operate on these separately, and then in the end combine them, right? So you make them 4, 5, 6 calls in order to do one thing, right? Langfuse, you basically add a little decorator so that it emits a trace event into Langfuse for each of the steps that you go through. Or in an agentic flow, each of the agents as it goes through, basically you'll have a log for what it sent to the model, what came back, how long it took, how much it cost, how many tokens of input, output, etc. For all the different steps. And we'll actually look at it in a little bit. It sounds really complicated, but it's super awesome because you can prototype with it relatively easily. You can see what your prototype is doing. And then as you graduate into production, it'll actually scale with you to being able to see your entire production volume and analyze it and being able to tweak it later on, right? And pinpoint, okay, what's not performing, what is performing, where do I have regressions, etc. And then in terms of vector stores, so a vector store, does everyone know what a vector is? In
Something with magnitude and direction.
Yes, a magnitude and direction, perfect. So when you semantically search, so search like by meaning, right? So RAG, I don't know, have you guys heard about RAG retrieval augmented generation, where you basically take a bunch of stuff, bunch of docs, and then you answer a question based on them, right? The way you find those docs that actually match is by doing a semantic search generally. Technically, you want to do a semantic search, and then also keyword search, and I want to do a bunch of re-ranking, et cetera, et cetera. I'm not going to go super deep into that. You're going to notice that a lot of the things I'm just scratching the surface on. I think every single slide I could talk about it at least 2 hours here today, so I'm trying to kind of go through it. And if I'm too long, just tell me. I need to move on. But basically, imagine you have a vector that has, I don't know, 2,000, 3,000, 10,000 dimensions. And you plot it on a 10,000 dimensional graph, and you plot another one there. And if they're close to each other in terms of doing the cosine similarity between the two vectors, then they're semantically related. If they're really far apart, then they're semantically opposite, as in they mean the same, right? So I don't know, probably things like different football team names, right? Are going to be relatively semantically related, if that's one of the features. That being said, a vector is really just an array of a bunch of numbers, plotting it on your however multidimensional graph. And if you are doing any kind of semantic search, you need a vector store to store those, and then to do your cosine similarity at scale ideally. So you want to have it nicely indexed, etc., so that you can quickly say, hey, out of these 10 million documents, I'm giving you a vector. Which ones of these are most similar to this vector I gave you, right? So in the RAG case, I have all my documents, my internal documentation maybe in there, and someone comes in asking, what are the sales for last quarter? Okay, figure out what the most related documents are, so you can shove those into the LLM. Like, hey, answer this user's question. Here's a bunch of random stuff that I want you to use as context for it. Splat it all in there, and then it'll print out a nice little answer, right? That's basically how all those things work. Even Notebook LM is just a really fancy rack system. If you guys have seen Notebook LM, it's pretty cool. One of the Google things, right? Makes even podcasts. All of this is a fancy rack system. Could build an afternoon. No, it's actually, they did a good job in implementing it. That being said, if you want to do prototyping, Weaviate is a great vector store to work with. It's really easy to get started, really easy to interact with. You don't even have to use something like LangChain if you don't want to. It can actually do some of the RAG flows internally. So you could even, instead of saying, no, just give me all the vectors that are similar to this vector, you can actually just send in straight up a query, like, and it then can interact with your model and give you, basically do all the RAG flow for you and give you the fully formatted answer back, which is really nice if you're first getting started. It's easy to work with. Elasticsearch is also really easy to work with, but it's a little bit harder to get an Elasticsearch cluster up and running. Weaviate is, you get your container running, locally, and you're good to go. We'll touch on vector stores a little bit here in an upcoming slide. Moving to production. All right, so you have to integrate it into whatever stack you run. Follow your own path. I'm not going to tell you what your stack is and what tools to use, whatever, right? You got to look at what's out there to evaluate, and then you got to make sure it fits into your stack. If it doesn't fit in your stack, you probably need to look at something else, because changing your stack may be too hard if you have an existing system. Don't forget about security. Security is a big deal, right? You want to make sure that your keys are secure. You want to make sure that you encrypt your communication. We're going to touch on security a little bit later again, right? But that's really important. Notice how this is very high level stuff, and that's because production is complicated. If you have ever released anything production, it is complicated. Things break and you have a lot of other concerns to deal with, right? But you have to find your own way. The prototype is getting you there. The prototype is where you try all this out, and that's why we're going to touch on rapid iteration so you can actually figure out how to get to that. If you are owning production quality GPUs, like some A100s, H100s, etc., which means that you probably sat on 150 grand somewhere and we're like, oh, this is burning a hole in my pocket. I need to put a heater in my closet over here. But if you do have that, or you have the luxury of having that through work, NVIDIA Triton is awesome for serving LLMs, especially because you can essentially multi-thread them. So you can really start hitting those GPUs and hitting them like fully utilizing them. You'll notice that if you only run a single inference model on there, that you'll, you maybe peg the memory, you'll probably never hit your cores. Sometimes you actually peg the cores, but not the memory. Triton, you can essentially multi-thread those, so you get squeeze more out of your hardware. So if that is a use case, go start looking at it and save you a huge amount of money if you're actually serving your own models. Prompt foo for evaluating prompts, right? For unit tests. It's huge. We have prompt foo for everything. It's integrated into the build process. It alerts us when something breaks. Like once you actually build a decent amount of GenAI into your system, right, into different flows, you need to know how they perform. You need to know that if the performance changes, and you need to know that they deliver what you want, especially when you're trying to upgrade a model, for example, right? So prompt foo is a great tool for that. It's not just me using it. Actually, Stripe's CTO put me onto that when he tweeted about it maybe a year ago. He's like, "Oh, we're standardizing what's it, Shopify? I don't know, one of the S's. We're standardizing everything in prompt foo." And I was like, "Oh man, let me go check that out." And I was like, "How did I not know about this?" LangFuse for tracing is amazing. I don't think it scales to hundreds of millions of transactions a day. That's okay. It doesn't have to, because you can kind of turn it on when you need to, or turn it off when you don't need to, or configure sampling, right? I'll sample like 5% of my traffic, something like that. But for most use cases, it's probably just fine. And then vector store wise, Weaviate scales reliably to few tens of millions of vectors. They've been working on scaling further, but we noticed once we kind of went past like 70, 80 million vectors, it became unreliable. And the synchronization between different cluster members was really taking a hit. Elasticsearch scales well beyond that. I don't know. I think the largest Elasticsearch cluster we got running is 84 boxes or something like that. And that's I don't know how many billions of vectors it's serving, but it's a large number and it's very efficient at it. Being able to say, okay, here's many billions of vectors, find me the top 100 that match this thing. It's pretty awesome. Production wise, there's a ton of vector stores out there. Once you start looking there, everything from the pine cones all the way to the fancy Elasticsearch. Same thing when you evaluate it, right? Look at security, look at scalability, look at the ecosystem, look at the licensing, look at the pricing, etc. Blah 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 blah. Tell you open source Elasticsearch is probably where you're gonna end up. Or Weavy, if you don't have to go past a couple tens of millions. Let's take a quick look at LangFuse. So it kind of makes sense what I'm trying to talk about. So LangFuse, this is their demo system. You just go to langfuse.com, click let me get in the demo system, and they'll kind of show it here. But imagine that you build some application, right? Has some GenAI in it, maybe it's even agentic. You deploy it out in prod, and you start seeing all your flow through it, right? You can keep track of your costs, right? You can keep track of how many traces are running through and what kind of models you're using. Here they've using GPT-4o Mini as well as text embedding 802 to generate vectors, which sounds like they're doing a RAG flow. And then let's take a look at tracing here. A little bit of laggy on the screen. So traces, imagine that these are all interactions that your users had with the system. I'm not going to show you our internal systems, but this is the demo system from LangFuse. So I'm going to drill into one of these just because it was like a 7-second execution. So in here you can see, if that's probably not large enough. Yeah, okay, that doesn't really fit that well once you zoom in too much. But you can see there's a bunch of different things on here. There's they did evaluations on here. This thing ran for 6.36 seconds, cost 0.00032 cents. It did a retrieval, so it pulled data from a data store. It embedded a prompt. Pardon me. Then it checked the vector store. So probably what they did is the user asked a question. They did an embedding, a vector embedding of that question. Then they hit their vector store and compared that embedding against that vector against other vectors, found the most similar ones and retrieved them. And then they did a generation here. And so actually, as you click on these, you can see what was going on in this thing. So it looks like the user actually, how can I get the session ID to set it to the traces? And it didn't do anything. Oh man, this sounds kind of like a problem. Let's see what the generation did. Okay, here's some stuff. You're very actually, this is the system message that they send over to the model, right? It kind of gives them some instructions, blah 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 blah, and then it had context along with it, as well as some history, some chat history, and then here's the output that came up back from the model. Why is this cool? When you deployed something and your user tells me, man, your chatbot is giving me bogus answers, rather than you having to write all the logging and everything else for this, you decorated a couple of few function calls and you have all that data in here and you can actually go look at it. And you say, oh man, not only that, but you can also, you've probably seen some of the chatbots where they get a little thumbs up, thumbs down on the generation. Hook that directly into here. And so I get a report of all the things that, on my chatbot were thumbed down, as well as all of the context around it. And now I can very quickly see what's going on. Why is that, right? When I did my prompt embedding, and then I did my vector store search, did it find the things that I wanted to? If not, why not? Is my data not good enough? Is my search parameters wrong, right? Is there something else going on? doing the generation, what was actually passed to the model? Do I need to change my prompt? Do I need to pass more context documents, fewer context documents, et cetera, et cetera? If you've worked with this stuff, this probably all starts making sense, right? If you haven't, it might look like a lot. Just know that this exists out there, and when you're ready for it, it'll be there for you. Prompt foo, just to kind of give you an idea, it kind of looks like this. It's YAML that we know and love. Oh, that's probably a little bit too big. You encode a bunch of your providers in it. So in this one, I was testing. I was comparing a bunch of different models for a particular summarization use case. Microsoft put out the Phi family of SLM small language models. I was working with the research team a bunch on their evaluations because we were thinking about maybe being one of their alpha customers. It didn't hold up to where I wanted it to be, and once we got it there, the price point was still not right. That being said, it was a pretty capable model, and they have a really cool team working with them there. But that's not the interesting part. The interesting part in here is that you have things like assertions. So in this case, I have a bunch of assertions in here. One is that, hey, I don't want this thing to talk about that it's phi. You know, like, oh, I'm phi. I don't want that coming back in my generations. I want I had this thing generate some JSON for me, so I'm making sure that it has JSON, that it has the proper objects in it, and they're of the proper type. I wanted to make sure that it doesn't have the little JSON decorator in there. And then for the tests, you know, there's some variables. So I pushed in different transcripts that I wanted summarized, and then I did my assertions on it, right? So this was really to compare, because some of the Phi models were really chatting, kept saying, "Oh, I'm Phi, and here's what I'm doing," and Microsoft didn't necessarily believe me, so I was like, "Okay, well, here's an example, and here's all the traces around it, so you can just look at it, right?" Very simple example. Our production prompt foo configs are a lot more complicated, and your assertions can be code as well, which is really cool, right? Maybe you can call out to a different API. So for example, in our system, we've got a particular search language that you can use to do stuff. When we have an agent that can create very complicated, complex searches for you, basically multi-component searches in our system, that it can generate all that for you by you just say, "Now I want to look at these kind of things," right? And then you can call out, for example, to an API, make sure that syntax is correct, things like that. So that's a really cool tool. In the end, what the output kind of looks like is when you run it, you've got your different runs and how they compare to each other in terms of scoring. You can turn on and off the different outputs. As a human, you can look through it and kind of see, okay, hey, here's the inputs that I had. Here's the latency, how many tokens it used, whether it passed my tests, whether it failed them, why it failed them, a bunch of different things. When you click in it, you can see what was exactly sent to it and everything. It's a really, really neat tool. QA loves it because they don't have to look at code. They don't have to copy and paste anything anywhere. They can rerun the builds. The integration pipeline does this, and it shows up in the centralized prompt foo instance. And they just click the little link in the commit message, and here's their view, and they can look at it. Oh man, I'm seeing some failures. I'm going to take a look at it and see why. Maybe I'm going to open a bug or something, right? So that really makes that flow a lot easier, because in the end, right, we're not just developers. We have teams that of users of various technical abilities, right? And so you want to empower them to do as much of the job as they can without having to become the best developer themselves, because that's not their core job, not their core role, and maybe not even their motivation. Any questions around this before I pop back in the boring black and white presentation? Okay. So let's talk a little bit about model selection again, and I'm going really high level on all this stuff, and so stop me if we've got to go deep on anything. Foundational versus custom versus fine-tuned. Foundational being just the big models that you get from the big boys or from the open source. Custom have a ton of data, train it on a ton of GPU time, get poor in the process, and have your own model. Or fine tuning, which means you take a base foundational model and you fine tune it with your own data, right? The pre-trained models, so like the GPTs, the llamas, the birds, etc., right? They achieve strong performance out of the box, I would say. And this is in order of kind of considering these things. If the out of the box foundational model does what you need it to do, that's awesome. Ship it, right? Faster time to market. You don't need a huge amount of data to train it or to fine tune it. That's awesome, right? If it does what you need to do with a little bit of prompt engineering, that's great. Maybe it's not quite as cost efficient as a fine tune. That's all right. Let's first sell this application, make a bunch of money, and actually justify fine tuning this thing, right? Custom LLMs can give you potentially better accuracy and lower inference costs if you're able to reduce the parameter count on them. They're generally used for specialized use cases, so legal, medical stuff, right? I would argue that is going to go away in the next year or so as the foundational models just keep slurping up all of the data, and you're going to have some players that are we already have a whole bunch of players that are just directly focusing on the legal and medical market. If you're trying to build your own LLM, you're probably going to be outmatched by them already if you haven't already been doing it for a while. It requires a specialized skill set and a lot of data, and that data has to be clean, right? It takes a lot of data prep. I don't recommend, except for pet projects, to train your own model. It's just not cost effective in terms of the time, the CPU cycles, the energy you put into it, and what you get out in the end. Now, fine-tuning a foundation LLM is something else that can boost the knowledge. I'm going to use that term very loosely, right? And or task accuracy. So basically what that is you give an LLM a whole bunch of examples. If you get this input, this is the output that should come out, right? And you basically train it on that and put a bunch of GPU cycles on it, right? It's great if you're having them, like for example, the Phi example. I used a more expensive teacher model, GPT-4o, actually, to generate a whole bunch of data of how I wanted Phi to behave in certain use cases that we were prototyping out. And then I trained Phi on that. And then I used prompt foo to compare base Phi versus different fine tunes and how it performed in terms of how I wanted it to perform certain tasks, right? And it got a lot better. And what happened is that I could get the Phi model, which ran, I think it was about, it's an 8 billion parameter model. I was able, on that specific case, on that specific task, I was able to get it to perform within 98% of the performance of GPT-4o, which is, I don't even know how many billion parameters because they don't publish it, but I think it's past 300 billion, I believe. It's 350 billion, is that right? I don't know, somewhere like there. That's what people are guessing at, right? So why does that matter? Because the more parameters you have, the more memory you need, right? And when you're trying to serve that thing, so being able to get a smaller model to perform on a very particular task as well as a bigger model is great because it can save you a lot of money. Because your inference is going to get a lot cheaper. That being said, it takes data, not as much as building your own, right? But it takes a good chunk, probably like a good 10,000 examples at the least, right? And the nice thing is that a lot of platforms offer tools for fine tuning. There's a ton of libraries out there and frameworks that do it for you. All of the hyperscalers have playgrounds where you're basically, hey, I put a JSON lines file up there with all my examples, and I click some buttons, and it does all this stuff without me having to learn PyTorch and whatever, which is great, right? Because again, we can all become data scientists, and data science is cool, but if your job is shipping product and making things that users find valuable, learning all of data science does not get you there, right? Especially if something's already been built that helps you accomplish that. And you can democratize it because instead of having to hire a bunch of data scientists and then them arguing over which, version of Python they like better all day, you can actually just do something. And then if I need to refine it, okay, now I'm going to consult with this guy over here that can tell me what all these things mean. Or I paste it in ChatGPT and have it explain it, and then I do a bunch of book reading, and next thing I know how to do this. And I know I'm oversimplifying some of this stuff, but it's actually not all that hard. You just got to start on it. My recommendation, try the foundational first, right? A lot of times they're good enough. Compare the different vendors, compare some of the different providers. Is Llama good at this? Is GPT good at this? And then find your right price point and go from there. You can consider boosting accuracy with context stuffing. So for example, in the RAG-based approach, right, you put a bunch of examples and more context in, you can really like boost the accuracy. RAG is really one of the common use cases, right? Answer this stuff, blah, blah, blah. I'm sure everyone's actually built that, and if not, you're probably going to build some of those pretty soon. And then fine-tune small parameter models with using the big voices as teachers, which means you spend a bunch of money on the big expensive models to generate the data, but you do that only once, and then you start using the cheap one that you fine-tuned yourself. Any questions? Yeah.
Just to clarify on the fine tuning process, so that would be like, for example, you'd have like an open source model, and you get you mentioned 8 billion weights. Does the fine tuning process actually change those weights? There's like an algorithm.
Essentially, yeah.
Okay. Multiple algorithms for doing that?
Yes, there's multiple algorithms, multiple frameworks. And then there's a ton of different variables that you can mess around with, like the learning rate, how many epochs you go, how you split your training set. It can get really deep, really fast. I would recommend that you pick a little use case you want to play with, and you give it a try, and then you do a little bit of reading up on what these different parameters mean. And then you tweak them a little bit and you see how the performance changes, and use something like prompt food to have very easy comparisons. You can also do a ton of reading. I like a hybrid approach. Like me personally, I learn best reading something a little bit, like at a high level, diving into it, and then supplementing my knowledge, right? That works for me. It doesn't work for everyone. Some people really like watching YouTube and whatnot. I can't learn anything from YouTube, which is a bummer because a lot of cool content out there. But like me, the reading and hands-on approach works best. I'm not saying I'm a data scientist. I dabble in data science, and I know how to get to value and how to sell value to either internal or customers. And I can get there by way of some data science, as well as a ton of other skills like architecture and whatnot. Am I going to invent the next LLM, et cetera? No. But I know at a high level how those things work under the hood. I know at a high level how I can tweak them. And, I'm not a mechanic. I can drive my car and I can change the oil on it, and it certainly gets me where I need to. And I know when I need to call someone when I can't fix it, and that's fine with me because I don't want to be a mechanic. I want to be a computer engineer, right? So this is the exact same thing. It's abstracted enough in the car model where you can deal with it, you can play with it, you can go as deep as you want to, but you don't necessarily have to. I hope that kind of answered it. It's a little roundabout answer. Let's see what's next. Okay. Screen's not updating. There it is. Which LLM? So there's a ton of them out there, right? How do I know which one I pick? Did I pick the right thing? Am I gonna get FOMO because all these new things are coming out? Maybe. To me, the best way to get started on this is get hands-on with the major LLMs out there to get a feel for them, right? Either make accounts at all the different providers to play with, go to some of the places where you can do the free playgrounds, right? Or use something like LibreChat and kind of build your own playground. Get a feel for them, get a feel for how to interact with them, how to get them to do what you want, what the capabilities are, right? If you already have that, awesome. Leverage benchmark comparisons. So artificial analysis.ai has a bunch of cool leaderboards. There's a bunch of different benchmarks out there of different categories of tasks that we benchmark different LLMs against, and then you can compare them. They're benchmarks, they're not real world, right? So they can give you an idea of real world performance, but truly what you gotta use that benchmark data along with actually trying that model out to really make a decision on it. Just because it's good at that benchmark doesn't necessarily mean that it'll be good on your very particular task type, right? Unless that task type is very similar to the benchmark. But it gives you a really good idea of saying like, okay, this thing is in terms of capability is relatively equivalent to GPT 3.5, Turbo 613, and comparing that to a Llama 3.1, 50 billion, it gives you something to compare things other than just vibes. Use prompt foo to run the same prompts or data through different LLMs and then compare. And especially if you already have like once you set up that harness, you set it up once, right? And then a new model comes out. Okay, cool. I want to run my test harness through and see how it compares to everything else, which is really valuable because you spent your time on it once, and then you can evaluate any new model that comes out against your own set of benchmarks, which may be your own test data, right? Or your own use cases. Because ultimately the benchmarks out there are cool and they're interesting, but they're not your data, they're not your prompts, they're not what you were trying to accomplish. You got to keep cost and latency in mind, right? The larger LLMs are slower and they're more expensive. This is probably pretty intuitive, but it is a truism, and we forget about that sometimes. And there's a trade-off between how good you need this thing to perform and how much you want to pay for it. And sometimes something that's just just well enough for what you're trying to do. You don't need to buy the most expensive, fanciest model if this small, cheaper one over here does exactly what you needed to, right? Important, don't worry. Like FOMO is real. This whole thing is overwhelming. It's turning over. I mean, there's a new discovery, once, twice a week. It can be very, very overwhelming. What if I picked the wrong model? Oh my God, well, if you abstract correctly, right? You use your engineering fundamentals, you abstract stuff, you can swap your LLMs at any point in time. Don't optimize too early. Which is just like it's just like building anything else in software. It's just a new meta. Don't optimize too early, right? Get it kind of working and then start optimizing. But see if you can even prove it out. If you spend optimizing on your very first step all the way through and then you find out, well, step 4 it can't do, well, cool. That sucks. Wasted all my time. Be prepared to swap. At some point, you're going to have to swap, whether it's for capabilities that you need, whether it's for cost, right? You want to get a lower cost model going, lower cost LLM going. The latency doesn't work for you, right? Or the model gets retired, right? Those things have lifespans, and at some point, in the adoption cycle, the providers are going to get rid of some of the older models just because they're not performing well, and people don't want to use them. They don't want to pay for them. So you're going to be forced to swap models anyway. So prepare for it by abstracting correctly, because you are going to change it. Whether you want to or not, at some point you're going to have to. You're going to get forced to, unless you really, really, really want to pay a lot. The cool thing is about these models is that they, at least currently, keep getting better capabilities at lower cost. So when we first started building these into things, we're using GPT 3.5, a bunch of the different flavors. Each time a new iteration came out, it had larger context, and it's cool, we can do more things. Some of them got more expensive, some of them got cheaper. And then 4.0 mini comes out, and it's like, man, this thing is like 1/35th of the price of the last one, and it can do 4 times as much. This is wild, but it works, right? And so if you set yourself up to swap out and have a prompt food harness that you can easily compare without just guessing and saying, well, this thing is cheaper and it's better, so it must be better, right? Because of the benchmarks. No, I can prove it. Prove me that this thing is better. Okay, I can. I push a button, it runs through it. Here's my report, and it tells them this thing is as good or better than the other thing that we're coming from, right? It really gives you a lot of flexibility, and it's not a lot of upfront cost to get there, because you kind of need things like unit testing, et cetera, anyway. Yes, sir.
So you talk about this on kind of like the text perspective, right? Text in, text out. We're facing the same problem with image. Like we're having an issue trying to kind of do what you do with prompt food, but only in the way of just with images itself. I mean, I'm basically the guy who is evaluating what's good and what's not, and that's not a good way to do it.
Yeah.
And so do you have any suggestions on how you could evaluate images on a much larger scale and have something kind of benchmark and test them out and say,
Yeah.
this is good, that's not good, this is consistent, that's not consistent. You want to do this thing with this image and it's not doing it consistently, stuff like that.
Are you willing to pay for this test for a fancier model? Like basically so, okay, so we're actually doing that at work. We have some prompt food flows that actually do like multimodal evaluation. One of the use cases is in an agentic flow. Imagine a user tells you, oh, make me a graph that shows this, right? And it actually creates the image of the graph, right? How do you know that it shows you the right stuff? How do you know it looks good? How do you know that the data on it is correct? That it maps to the data that you wanted it to, that it follows the right formats and standards, et cetera, right? So we actually have a prompt food harness that uses as an assertion a little bit of code, and in that code, we call out to which model was it? I think 4.0 Turbo. No, not 4.0. Yeah, the latest 4.0 multimodally. Pop that graph in there along with, hey, this is the information that it should be shown. These are the guidelines it should be, and here's a reference image of what this thing should look like in terms of styling, etc. Right? And it's actually really good. And then say this is the here's how I want you to give me your feedback, right? In a more structured format. And then we have that come back and actually use that in prompt food evaluate assert on that output that comes out. So we're basically using an evaluator model, right? That's a little bit more expensive than the models that we use for different generations and whatnot, but that's okay because in my tests, I can afford that, right? And it's way cheaper to pay for a more expensive model to do that work for me than doing it by hand or having any other human.
Okay. Now you said it's just for graphs. Are you doing it for any kind of other types of imagery? I know I'm saying it very abstractly, but
yeah, no, it's mostly on around graphs and charts, but I can see that working with a little bit of tinkering. I can see that working for almost anything. I use GPT-4o's multimodal a lot personally. Like for example, for my kids, a lot of times when they come home, they're like, "Oh, I got a quiz coming up," and I'm like, "All right, well, give me your practice sheet," and I take some pictures of it and be like, "Hey, make me some practice tests based on this," and things like that. Or like I said, I'm not very mechanically inclined, but my lawnmower wasn't starting, so I just took a picture and was like, "Hey, I don't know which one, what's the carburetor? Can you please walk me through how to fix it? And which pieces to take apart and it doesn't?" Like the multimodal capabilities of that are actually quite amazing, and I would just try it out. It does mean that you maybe need to. And if it's not possible today, it'll be possible in 6 months, three to 6 months. And so you can build it 80% of the way there. Get whatever cases you can covered by now, right? And by the time the model capabilities upgrade, then you're golden, right? So even if you can cut out 50-80% of your manual effort that way, right? That's great, right? Because that's money right back in your pocket.
Yeah, great. Thank you very much.
No problem. It's actually a really interesting point. Like you can do stuff with these things if they're creative, if you're creative. And remember they can mix and match model capabilities. You can mix and match different multimodalities and try things out. And you may be very surprised at what you can do with it, right? And sometimes you hit a wall and they say, okay, cool, I'm going to try it again in 3 to 6 months. And so far every time I've proven right. Actually, by the time we're finished polishing a feature, we can actually just usually go to the next level model because we build it to almost work, and then we flip it out, and boom, look at this! I beat everyone else in the market on it. We've done that a couple times actually over the last year and a half. Let's see, rapid iteration. That feeds right into that. An experimental mindset. Especially as you're building with this, right? Try things out. There's a lot of different models, a lot of different capabilities out there. You may be surprised what you can do. And if you can't do the super complex thing, break it down into a couple pieces and try the different pieces. Maybe you can automate half of it. Maybe you can automate 80% of it. And then later on, plug in the last 20%. These things are constantly expanding. So don't be afraid to build applications that almost work, right? And then later on, just swap out the model and you got your killer app. Because if you're waiting until that model can do what you need to, I already built this. And now I'm the one that's capitalizing on it and you're not. That's awesome for me and sucks for you, right? So you don't want to be that guy. You want to be the guy that is ready to pounce that opportunity. Iterate, 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 iterate. Developers. Build with different LLMs. Like get the feel for the different things, for the different capabilities. Work on your prompt engineering, right? Does this thing work better if I tell it to think really hard? You know, if I say some please and thank yous, will it do better? I don't know. We'll try it out. There's a lot of different prompt engineering hacks that work for different model families. Try them out. If you have a prompt tool harness, you can actually try them all out once you have them put in. Actually, I wouldn't be surprised if someone already made a prompt tool GitHub somewhere that has all those in there. That reminds me, I should probably look for one of those just to see if there is, because if not, maybe I should do that because it would be pretty fun. Fine tuning, same thing. Run an experiment, fine tune something. That's like, you know, 50, 60 bucks usually to do a fine tuning run for a couple hours on a, you know, 10 to 15 billion parameter model in Azure OpenAI. It doesn't break the bank. You know, it's not super, it's not, you probably don't want to do it for a hobby case, but if you're doing it professionally, you know, what's 60 bucks to potentially unlock some really awesome capabilities, right? Iterate on it. And don't be afraid to abandon an approach if it doesn't work. Man, this didn't work. Okay, well, hang on. Let me back up a little bit and see if I can change something, right? Maybe I can break this down a little bit. Maybe I can use different capabilities. Maybe I'm thinking about this the wrong way. Maybe this is actually just a plain old code problem. Maybe I don't even need an LLM. That's actually a really important thing. Like, you know, we like to throw the new tools and everything. There's a lot of problems you can solve with just plain old code. If you don't need it to reason, yeah, we can. I mean, technically, these things are just really fancy switch statements, and you could say. But if you don't need it, don't use it. Yeah, I'll leave it at that. But don't be afraid to say, you know what, this didn't work. Let me back up a couple steps and try again. Because, you know, maybe at some point you're going to come back. I've had that actually. I hit a couple of walls. I'm like, yeah, I'm going to abandon this. Come back 6 months and you're like, oh man. I can go back to my idea over here, do a couple of tweaks, and all of a sudden it works, right? It's pretty sweet. Like the ecosystem changes so fast, you gotta be able to change your own process and your approach pretty fast sometimes. In terms of staying agile, right? You gotta bake agility into the design. Follow best practice for modular and extensive architectures, right? Microservices, service-oriented architectures. You want to decouple your GenAI so that you can independently update it. That's really important, right? You got your big stack. Do I need to change everything in my stack in order to upgrade my model? If the answer is yes, then I did it wrong. What if I want to switch from my regular LLM invocations into a more agentic model, and I want to put a bunch of agents in my ecosystem that are orchestrating, you know, some very complex tasks by themselves? Well, if I decouple that from the rest of my architecture, that's actually pretty easy because now I got to deal with just a couple of interfaces that abstract all that implementation over here, right? I mean, this is just engineering 101, you know? Same thing we've been doing since the 50s, 60s, 70s, just with different tools. Swappable components, right? Be able to swap your models, swap your retrievers, swap your pre-post processors without rebuilding your entire pipeline. What if I need to use this is, I mean, helped us a bunch. What if my vector store doesn't scale all of a sudden because it seemed like it was so good and they said it would scale? I hit, you know, 70 million vectors and it's no longer scaling and I'm having outages. This sucks. How do I change that? Well, if I abstract my interfaces well enough, I can switch over. So we went over to Quadrant. Quadrant sucks because it doesn't have enough metadata storage. Okay, so then we ended up with doesn't matter, something else. That thing didn't scale well either. It kept falling on its belly. Elasticsearch finally expanded their vector storage sizes, and it's like, okay, well, let's try out Elasticsearch. Oh, sweet, it works, and it does everything we needed to, and we already had a big cluster. Let's just double the size of it, and here we go. Perfect, right? And you can do that if you architect your software well. Software architecture is an art and a science. And so we're not going to go super deep into it, and we don't have a whiteboard, though I would love to draw a bunch of architectures. That's probably actually my biggest miss that I miss about the office is not having a whiteboard to just go wild on while we're solving the world's problems. But I digress. Keep in mind that you will change models and your prompts and stuff at some point. It's going to happen. It's going to have to happen because the models go away, et cetera, right? For everything we talked about. So you want to abstract your model interfaces and the configuration for them. Some of the frameworks do that automatically for you and force you to that pattern. So that's great. If you build your own, make sure you do that on your own, right? That's good practice anyway. And you want to centralize your prompts. What do I mean by that is rather than having your prompts, inline in source code all over your code base, have them in one spot in your code base. Or if you want to get real fancy, serve them from an API or from a database or something so you can quickly upgrade them and roll back. LangFuse, if you pay for it, LangFuse is open source, but if you pay for it, it actually has a really cool prompt centralization system in there where you can have version all your prompts, you can roll them out, you can A/B test them, blue-green them, etc., right? And then see how they perform in your different traces and whatnot. So that's a really cool system. Wasn't right for us because we predated good engineering practice and we built our own prompt centralization already by the time that came around. But if you're starting now, that's something to investigate. And then really important is don't forget about your team culture, right? If everything's evolving so fast, your team will have to evolve and keep pace with it. And it can be exhausting, right? We all know how hard it is to constantly, we're developers, right? You constantly have to learn. It never stops, right? But you have to set that culture. It's easy sometimes to get stale, right? And you get kind of complacent. And you're like, hey, I'm good. I can do this stuff, right? And then all of a sudden, your boss is like, everyone has AI. We need AI. And then you're like, oh crap! Now I have to learn everything in the world. If you already have that culture of keeping pace and learning and evolving yourself, right, and your skills, it becomes a lot easier. And if not, you got to foster that culture with your team. You got to embrace failure and experimentation, because really failure is how we learn. In Boy Scouts, one of the really nice things about Boy Scouts is that it's a place where you can fail, right? You fail in school, you get an F, you flunk out. You don't get a scholarship, you don't go to college for free. Man, that sucks. If you make a mistake out on the streets, you might go to jail, right? Or you get killed in a car accident, right? In Scouts, the nice thing is you have a space where you can make mistakes, you can learn leadership, etc. And it's the same thing here. You want to have an atmosphere where your team can make a mistake and not get crucified for it. Because a mistake is how we fail. The real skill is failing as early as you can. And the way you fail early is by rapidly iterating and getting to the point of failure where you can say, this doesn't work. Let's try something else. You don't want to go for 6-9 months to find out this doesn't work because we slowly plod along. But that's big of team culture. And then training and skills development, right? You got to give your people the ability to gain those skills and to exercise them if you want them to be applied in building these kind of things. That comes over to learning and staying up to date. Play, build, read, or watch. Watch doesn't work for me, but my son watches YouTube all the time and learns all kinds of stuff from it. I don't know how he does it. Even while playing a video game, it's amazing. Must be the ADD. Doesn't work for me. But stay on top of it. Theory is great, but it doesn't trump hands-on experience. Ideal is if you can balance hands-on experience with theory. If you If you know how a compiler works, you're probably a better developer. But you don't need to know how a compiler works in order to be a good developer. But it may make you a little bit better because you understand how to optimize, etc. Right? It's the same thing here. You can start building with LLMs without fully understanding them, and then start filling in that information, because just like if you know how to optimize your code in order to get better execution times on something, it's the same thing with LLMs. If you understand how the tokenizers work and how the different transformer layers interact with each other and whatnot, you can actually start understanding why do different prompt engineering hacks, like asking it to go step by step before replying, actually work, right? And then once you understand how that affects the transformers under the hood, then you can start applying that to other pieces of your prompt engineering, for example, right? Or better understanding how to provide data to the thing so it does whatever you want it to. But you don't need to do that. Start with a hands-on and then supplement the theory later. If you start saying, man, I need to learn everything about LLMs, all right, I'll meet you in 5 years when you're ready to actually do your very first thing with it. Because there's so much to learn. Follow the news from the major model providers, right? The OpenAIs, the Anthropics, and whatnot, so you can kind of see what all the buzz is that they're trying to market to you. Follow the open source news. There's a lot of open source models out there. Kind of follow us around. There's a bunch of different venues to do that. Read research papers. There's a lot of research papers getting published. Some are good, some are really great. A lot of them are kind of just getting published so that you have something published, right? Does everyone know the trick to reading research papers without spending 45 minutes per paper?
Use Notebook LM, and I have in front of if I just have it run as a podcast, I also have some questions and get feedback all I need.
Perfect. That's one very good thing, right? Using AI to do that.
My professor just told me to skim through the paper.
Skim through the paper, right? I always read the first paragraph and I read the last one. And if your problem statement and your conclusion don't make sense, I don't need to read the rest of the 10 pages because it's just drip. But if what these people came up with is really cool. Now I'm going to start looking at how they're doing it and go from there, right? But that's how you can have a day job and still read 5-10 papers a week without feeling like that's all you do, right? But if you do skim through a couple, and it's kind of like a skill. After a while, you're like, oh man, I really breeze through these papers. You find those couple of papers that just like all of a sudden you have an idea like I can use this. And that's very similar to what we're doing over here. Maybe we can do a tweak, and it's just amazing what the kind of pieces you can find.
Do you have a good resource that you'd recommend for that?
Yes. Actually, this newsletter down here, TLDR AI, which is at tldr.tech/AI, is great. Basically what that is, it's a daily newsletter that gives you some industry news at the high level. It gives you a bunch of research news, which is there's usually links to like 4 or 5 papers that came out in the last 2-3 weeks that are really interesting or getting buzz. It goes over different legal issues that are going on. It's a really great. Oh, am I over time? Okay, cool. Just double checking. Keep me honest on the time, please. I think we're getting for 5 minutes. Okay, I'm gonna breeze through it. Okay, TLDR Tech AI. It's great newsletter. Read it every day. You'll get really smart. I like this guy, Simon Williamson. He's got a cool blog, bunch of stuff, posts every other day or so on it about all the new models that he tries out. I like his philosophy of building things. It kind of aligns with my own, so that's pretty cool. A ton of the AI researchers migrated from Twitter over to Blue Sky, so that's a place where you can go to like get a lot of the fire hose. It's very similar to early Twitter, where you just basically have a bunch of techies doing a bunch of talking with each other. It's really awesome. Estimating costs. Oh my goodness, 5 minutes. Okay. This is actually the important part, right? So how do the providers charge? Stock foundational LLMs, the cost models are consumption, deployment, rate limit. Consumption is you can either on demand, pay as you go, which is what we saw with replicate, right? Versus pre-provision versus batch. So pay as you go is I submit, I get stuff back, I pay per token, input, output. Pre-provision means I have pre-provision capacity that I can use. If I go over it, I get a 429. If I go under it, I still paid for it and I didn't use it. Man, that sucks. Don't like it very much myself. Batch is I don't have a real-time need to get my data processed. So I'm going to submit the batch and they're going to run it through the system within 24 hours in their spare capacity. And I get my answers back, right? Generally really cheap. Deployment-wise, global versus geo versus region. Generally, the global deployments are the cheapest because that means the provider can just stripe the load through their entire global infrastructure in order to use all the spare GPUs that they have. However, you may have legal requirements to be region specific, right? For example, UK has a lot of European Union obviously has GDPR, et cetera, right? So you want to make sure you keep your data there when you're processing it. And then the UK has a lot of data localization concerns. So you may even want to just keep it in the UK as you're doing your processing. And then rate limits, right? That's usually in tokens and requests per minute. So yeah, how many tokens can I put in? How many requests per minute can I call? The costs are generally calculated by input and output tokens. A token is the basic text unit that an LLM operates on, right? It can be a word, part of a word, character. It really depends on the provider. OpenAI, for example, uses tick token, which is a little Python library, so you can actually do your own token counting with it, which is great because when you estimate your cost, you want to figure out, okay, what's my input output going to be, right? So you can count your tokens that way. Or you can use something like PromptFu and LangFuse to have it done for you. And then prompt caching, something you got to keep in mind. Prompt caching, some providers offer, and that is basically caching the first X tokens of your prompt, right? It generally has to be at least 1,024 tokens that have to be the same across every prompt, right? And those are then cached across your different iterations. And depending on the provider, you're going to get a 40% to 90% discount on those tokens. When is that useful? When you have, for example, a really large prompt that has a ton of examples, like few shot examples, for example, in there, right? So that could really add up if you cut out 2,000, 3,000 tokens worth of cost each time. Fine-tuned custom LLMs, you're generally paying for the time on a GPU instance. So you're gonna pay spot versus on-demand prices, right? Spot prices, basically, spot instances can go away at any point in time. They're just using the spare capacity that the provider has out there. On demand, you're renting that box, basically. So those are going to be more expensive. However, it means that your idle time will run up costs, right? And that's for me, one of the drawbacks of a fine-tuned LLM hosting, being that unless you really model your capacity well, right, and your demand, you're probably leaving money on the table. Here's the one graphic that I put in here as a joke. How did you end up in poverty? I left an EC2 instance on. Who's ever blown 100K away by accident EC2? It's the modern equivalent of deleting system 32 or RMRF, period. Right? I mean, it happens. So it can very easily with your spot instances and on-demand instances, you can throw away a lot of money. You need to model your usage. In order to do that, you need a representative data set so you can have an accurate estimation, right? You want to figure out what's my daily throughput, what's my hourly throughput, what's my per minute throughput, ideally. That per minute is important when it comes to rate limits, right? Because most of the providers will have a token input output limit as well as a request per minute. So you need to make sure that your requests per minute are actually under that limit, or you're gonna have to potentially encounter latency in your process. You want to estimate your input tokens, right? Input is what you send in, which is your static prompt, which is your instructions, examples, etc. And your data, right? So whatever you got your static prompt, you got your data that you're sending in, right? How big is that? You need to transform your data before you pop it in, right? Because you need to count your tokens in the format of the data that you're actually sending to the LLM. Output tokens, same thing, run a bunch of examples, right? And then figure out what is your ratio. Do you have a static ratio from input to output? Like for a lot of summarization cases, for example, for in our case, it's generally 1 to 10. Or does your output length vary based on the input? So annotation, right? I want to annotate this data. So then it's usually maybe a 1 to 1, right? If I put in a lot of data and then I want it annotated, right? It's probably going to be about as large as coming out. If I do RAG, I have a lot of context I'm stuffing in, but maybe just a little bit of data coming out. Or it's a really long answer and I have a different ratio. So you need to figure that out based on a bunch of examples. Spreadsheets are awesome, right? That we can plug in all your numbers. And if you change if pricing changes or volume changes or whatever, you just update those fields, right? And you got new data out there. Make sure, and yeah, is your prompt already tuned? Will it get shorter or longer, right? If it's not tuned, it could get shorter. That's great, cheaper, or it could get a lot longer if you want to get to the right performance. Is your prompt large enough to trigger prompt caching? If so, you got to include it in your cost model. And then bake in at least a 50% buffer, right? Because we all know our estimates are always off by at least 15%. I was actually one of the ones I was within 0.2%, and I was very proud of myself because it was very predictable data. Estimating costs. So this is looking future. Test time compute heads up. We're seeing a new important dimension emerging in model costs out in the industry. That's test time compute. And we're going to start seeing that in 2025. Not a lot of people are talking about it, but I see the writing on the wall. The reasoning models are coming out, right? The 01, 03, you probably have seen that, oh, hey, it pops in there, does a bunch of chain of thought under the hood and then pops up. Turns out that they're actually getting higher accuracy on a bunch of benchmarks if you give them more time to think, which really just means shoving more GPU cycles into that thing. And we're most likely going to see that represented in the pricing that comes out. This little graph over here is the test time of 01 from accuracy. Notice that the test time compute is a logarithmic scale in order to get better. This over here was like, what, 10 grand, I think, of compute just on a single answer, right? That is going to be reflected in the pricing strategies. Maybe it'll be translated into input token context. I don't know, but that's something to be aware of if you're starting to go over to the reasoning models. Yeah, here's 10 grand for 03 high tuned. Handling scale. Do we want to just go real fast? You tell me how much time we have.
About a minute.
A minute, okay. It's just engineering. Do the same thing you always do with engineering. Proper caching. Don't do if you use caching at the right spots. If you're handle any kind of 429 rate limit from your provider, and ideally be able to stripe across them and load balance your data. Figure out what your latency acceptability is. Do you really need real time? If not, just go to batch inference. And bias is boring. You can just trust the people. You can do a lot of stuff. Red teaming, Promptfoo has a bunch of stuff for red teaming, which basically is trying to see if the model will give you bad stuff. So you can kind of learn from there. There's a bunch of different stuff out there. Do some reading on it. Data privacy. Keep in mind, if something is cheap or free, your data is the product, either you or your data. So you got to make sure that the data you're sending is something that you're okay with giving to someone, unless you're paying for the right to privacy. Most providers don't actually give you full privacy. Some will persist your data, and then they will use it for training models. A lot of them will actually charge you extra to not persist your data for them to train models. So make sure they keep that in your cost models. Even if it's okay with you, is it okay with your customers? Is it okay with you legally, right? It may not be. Depending on what kind of data you're working with and what kind of EULAs you got going on. Azure OpenAI, in my experience, has the best privacy controls. They're the only major provider where you can say, do not write down any of my data ever. Doesn't matter if you hit any kind of filters or anything like that, don't do it. It's the only ones that will also give you a CCC, which is a customer copyright commitment, which basically means any code generated by it is covered by Microsoft Legal in case someone comes and says that you ripped off their code that came out of generative AI. which is awesome. Microsoft Legal will take your case for you. No one else does it, including Amazon. And I keep looking about every 2 months because I really want to use some of my models for certain internal use cases where I want my devs to be able to use some code generation from it. But my legal team tells me they're not going to do it unless they they indemnify that code that spits out is not covered by copyright somewhere. Azure OpenAI is the only ones that actually do that. That's awesome because Microsoft Legal is something to, if you're on the wrong side, terrible. If they're on your side, awesome. Anonymized, pseudonymized data, right? Any PII, rip it out before you send it in there. Then you don't have to worry about it as much. Safety, do some content filtering, stick the human in the loop, kind of makes sense. We're going to see more human in the loop requirements and AI regulation coming out. You can do a bunch of reading on it. It's cool. Log your interactions, have a process to deal with escalations on it. It's pretty straightforward, I mean, just normal stuff when you're building products. Security-wise, protect your custom fine-tuned models, right? And your data, because that's your gold, basically, right? If you're using the stock foundation models, use all the basic computer science 101 security that you have out there, right? Put authentication in the RBAC, TLS, etc. It's pretty straightforward. We do it all day, every day. Regulations. You got to be aware. There's a bunch of stuff out there, right? What regulations apply to your domain, PCI, HIPAA, etc., right? GDPR. Well, you got to figure out what those are. Make sure that you have your compliance strategies in place, right? That's pretty straightforward stuff. Make sure that your legal team is involved. California vetoed their AI Act, so that's cool. We don't have to worry about it right now. I think with the incoming administration, we're going to see a free-for-all and basically zero regulation on AI in the next 4 years in the US. However, in Europe, that's the polar opposite, where we have the EU AI Act. Go to their website, Artificial Intelligence Act.eu, and read up on it. It's really interesting. I'm not going to go deep on it. It came into effect in August. In 1 month, the first provisions apply, and then they're going to start coming into different things. It basically says that, hey, you got to classify your AI application into 3 different risk categories, and then depending on the risk category, you have different obligations you got to deal with. Just go to this website. They have a really, really good summary on there, on their stuff, so it's not hard to do. Q&A, we're out of time. I'm sorry, but we can talk offline.
Thank you, Felix, and thank you, everyone. Are you staying
Yeah, I can stay about half an hour.
half an hour? Okay, so usually for the